Good evening, everyone, and I guess good morning for some of the folks here in the US. Um, Along with my co-host Sundravali and Gautam, um, I'm Rajesh Tyagi. I'm the president of the Informs Practice section. And before we get started, let me just talk a couple of minutes about the practice section. Gautam, would you please go to the next slide?
Yeah.
Yeah. Okay. So Informs basically is the Institute for Operations Research and Management Sciences. This is the premier professional organization for this technology area. And practice section is a very active community within Informs. It targets basically or supports mainly practitioners or those who work in the industry. To that end, we have hold a number of competitions and different events. We have been given the responsibility and, in fact, the honor to run three major Informs level competitions. We have the Franz Edelman Award, the very famous, well-known award, which focuses on applications which bring huge benefit to the organization or their clients or the general community. We have the Wagner Prize, which focuses a little bit more on the technology innovation. And we have the UPS George Smith Prize, which rewards universities which have a data science program that better prepares students for industry. So all these three are major Informs level competitions that the practice section is responsible for executing or running every year. These are annual competitions. I'll just talk briefly about a couple of other activities that we found. We have the Applied Analytics Success Stories webinars, essentially applications which are in use and have been very successful. And today's presentation is an example of that. This series also includes a special series on generative AI, especially how it affects ORMS community. We also have a virtual networking happy hour, which is held last Friday of every month. We have a very innovative format there. Basically, people are assigned to virtual rooms with 4 or 5 other people. They get to talk about some general topic related to ORMS. They get to know each other, and after 10 minutes, they get assigned to different rooms. So this is more for networking, very popular format that we have got the feedback on. So again, these are the major activities of the Informs Practice section. I'll hand it back to Gautam.
Thank you, Rajesh. So I am Professor Gautam Datta, retired faculty from IIM Ahmedabad, and I have been a past president of ORSI and national president of ORSI. And in fact, I am particularly interested that in India, we should be having more practice-oriented work. So we in the ORSI Ahmedabad chapter, now I'm only concerned with ORSI Ahmedabad chapter, connected with ORSI Ahmedabad chapter. We decided to do two things. One is that have a webinar, which we are having like this, at least 3 to 4 times every year to demonstrate the where good practice is happening in India. And second, we do a practice prize competition. So we have a core team, which is myself, then Sanjay Kumar Prasad from IBM, Siddharth Sengupta from TCS, Sankarsan Basu, IIM Bangalore, Sundarabali as the president of local chapter, Sumita Nates is Nirma, working in Nirma, Bodha Ramkumar is Swiki in Bangalore, Mrinali Sarma in Delhi, and Ranganathan from MBI Gurgaon. And we have held this competition 2018-19 twice. And last year also we had this, when in fact that happened in this year. The competition was organized completely last year. The event happened this year. And next competition is going to happen in 11th of January. For that, last date of entry is provided. And we are strongly encouraging people who are doing applied work to participate in this competition so that we get a better idea how that practice is being done in operation research. It is very much important today. With this, I would again hand over for today's talk. And we have today delighting 1 billion Indian customers through supply chain optimization of the Flipkart. Pratik Agarwal, Director of Product in Flipkart, Dr. Gautam Bilala, Principal Data Scientist in Flipkart, and Dr. Vikas Goel, Senior Director Data Science in Flipkart. All of them has done a very good, outstanding work in applications of uh, operation research in the real world practice in the Flipkart. I think they were selected as a finalist for the prestigious Franz Gentleman Award. And this Franz Gentleman Award is considered to be the Olympic gold medal or Olympic medal, or Franz Gentleman Award is considered to be the Nobel Prize in equivalent of that by the informs. So I now am not going to take any more time. I think I'm going to hand it over to uh, Dr. Vikas Goel, who has led the team and who will be giving you the presentations. I heard their presentation, but I was a part of the panel of the jury of the Edelman project this work. Over to Vikas. I'm going to close this. Okay.
Thank you, Gautam. Hello, everybody. Good evening and good morning. Thanks a lot for the opportunity for us to talk about our work. In our presentation today, we will talk about how we at Flipkart, which is India's largest e-commerce company, we've revolutionized how supply chain operations or our supply chain operations by building a central planning platform. The supply chain at Flipkart is built to acquire and store seller inventories in our warehouses and then deliver them to our customers. Planning plays a key role in helping us deliver these shipments at the fastest speed, at the lowest cost, and then at the highest reliability to our customer. So in our presentation today, we will talk about how we leverage machine learning and operations research to transform our supply chain and deliver significant cost savings and incremental net sales. We won't be able to talk about specific numbers on those two metrics, but I mean that's driven by the fact that Flipkart is not a publicly traded company, so some of those details we cannot share. But I mean the numbers that I mean the savings and the incremental sales we had were pretty significant at Flipkart scale. We accomplished this transformation over a short period of 3 years, and that was during a time where Flipkart was growing pretty rapidly, and also our market was evolving, given the growth in the market and the pandemic that was happening, right? And as Gautam said, this work was recognized as one of the finalists for the 2025 Franz Edelman Award. In fact, we are going to be using most of the material that we are presenting is pretty much from the presentation that we made in Indianapolis earlier this year. So, right, so before we go further, we'll just do a quick round of introductions. My name is Vikas Goel. I'm Senior Director Data Science at Flipkart. I have a bachelor's in technology from Carnegie Mellon, from IIT Delhi in chemical engineering, and I did a PhD with a focus on optimization OR at Carnegie Mellon. I've been working at Flipkart for almost 4 years now. Gautam?
Hey, hi everyone. This is Gautam Belala. I'm a principal data scientist at Flipkart. I've been with Flipkart for over 6 years now. My background is primarily in machine learning, and at Flipkart, I've been working on very interesting problems at the intersection of machine learning and operation research. I'm very excited to be here today and share our journey. Thanks for the opportunity.
Hi everyone, I am Pratik Agrawal. I'm the Director of Product for Sourcing and Fulfillment at Flipkart, and supply chain and inventory planning is one of the few areas that I own. I have a BTech from IIT Roorkee in Production and Industrial Engineering, where I think my love with operations research first started. Consequently, I did my MBA from IIM Calcutta. I've largely worked across consumer internet, across product strategy, business roles, and I've been working with Flipkart for over 4 years. We'll jump straight into the presentation. So, because, yeah, cool. So, this is a largely Indian audience, but let me just quickly talk about Flipkart as well. Right. So, we started back in 2007, as most of you would know, by selling books online. And today we cover just about everything, right? So, electronics, mobile phones, clothes, grocery, and even two-wheelers, two-wheeler automobiles. Flipkart has it all. We have a history of innovation, creating many of the firsts in Indian e-commerce, which have paved the way for the growth of the Indian e-commerce market. Some examples are cash on delivery, our Big Billion Days, which were one of the first big online shopping festivals in India, and a multilingual app that we launched back in 2020 to serve the vast lingual diversity in India. Today, we are the biggest e-commerce marketplace in India, and we lead a market which is full of global heavyweights and local innovators. We serve over 500 million registered users and offer a vast selection of 150 million products, connecting customers with 1.4 million sellers. We serve just about every Indian zip code that is out there and are the leading logistics provider in India by volume. Our mission is simple: to delight a billion Indian customers by providing them with a seamless and reliable shopping experience. Now, as in any e-commerce marketplace, our supply chain focuses on two major flows. The inventory procurement and placement flow, which is focused on making the right products available as close to our customers as possible, and the customer delivery flow, focused on ensuring these products are delivered to the customer quickly at the lowest possible cost. In our procurement and placement flow, inventory is procured from various sellers across the country, across a multi-tier network of fulfillment centers, or FCs as we call them. These fulfillment centers can range from big, deep reserves having millions of cubic feet of storage. I think, if I'm not wrong, Flipkart owns the biggest, one of the biggest fulfillment centers in all of Asia, to micro fulfillment centers or dark stores, which are as small as 2,000 square feet and are typically located in your neighborhood. Now, different models of inventory procurement exist, from direct inwarding at these fulfillment centers to procuring at some of these large fulfillment centers and then moving inventory from one fulfillment center to another, all with the aim of making the right inventory available as close to the customer as possible. On the other hand, our customer delivery network is a complex system with multiple hops that spans multiple nodes and involves various stakeholders. Shipments move from the fulfillment center to the mother hubs, which sort, aggregate, and reroute the orders across various nodes till the packages finally reach a delivery hub. Each of these thousands of delivery hubs serve a cluster of zip codes, and delivery agents pick up packages at these delivery hubs and make the final delivery to the customers. Now, each leg of this journey, from the FC to the final customer, is carefully orchestrated and planned for to ensure the fastest speed possible at the lowest cost. Moving on to how we plan this, at its core, planning and running these flows is a resource allocation problem. For the inventory procurement and placement flow, it's about helping sellers allocate their inventory in the best way possible across locations and time window. Hence, under inventory planning, we focus on optimizing the inventory quantity, its placement, replenishment, and liquidation to achieve high inventory availability and delivery speeds to our customers, while improving working capital efficiency for the sellers. Similarly, for the customer delivery flow, we need to allocate and plan for resources like manpower, trucks, and delivery agents to meet our goals. Under capacity planning, we focus on allocating manpower and logistics resources at each of the node of delivery network to achieve reliable high delivery speeds at a low cost. Key planning decisions here include how much manpower to staff each of the nodes with, how much capacity to operate each of the nodes, as well as the allocation of load between internal and the diverse third-party delivery carrier network that India has. Each of these decisions has a significant impact on delivery speeds, costs, and overall customer satisfaction, and need to be planned accordingly. Network flow planning is focused on optimizing the network flow to improve the speed and cost per shipment that can be delivered from the network. Key decisions here include flow routing, sortation planning, and middle mile solution. Now, these business processes are not really happening in a silo. They take inputs of a forward-looking demand plan from a demand planning process that runs at a category level and at a product level. In this process, a category level demand plan, for example, the number of earphones sold on each day of the month across India, is created and aligned across all teams in Flipkart. These are the kind of plans that serve to focus the entire organization into a single goal, right? Now, these plans flow to each individual category team that create a product level demand plan at a regional level. For example, let's say the number of Apple AirPods to be sold each day in a state like Karnataka. Now, these category and product level demand plans serve as the base for all downstream decision making, and improving accuracy of these plans improves the accuracy of our downstream resource allocation decisions. Let's quickly hear from Vikas Sinha, one of our primary business partners, on the challenges they faced before we launched the central planning platform. Vikas, it's not audible.
It operates in an e-commerce market, which is extremely dynamic.
Can you not hear?
We can hear now.
Okay, let me play it again.
Hi, I am Vikas Sinha, VP of Demand, Supply and Inventory Planning at Flipkart. Flipkart, as such, look at it operates in an e-commerce market which is extremely dynamic and competitive. Our customer base is rapidly evolving and demanding more from us every day. The rise of quick commerce and the online fast fashion are some of the recent examples. And Flipkart as a company need to move very, very quickly to compete in these markets, or the risk of losing its leadership position. Our customer base as well is very, very diverse. There is one section of customer who are ready to pay more for convenience or quicker delivery, while there is another segment which is fine with saving money, even if the delivery takes the entire week to deliver. And hence, the one size fits all supply chain does not work for us as a company. The 2020 was also a paradigm shift for all of us, where we saw a lot of changes happening in the e-commerce market due to COVID. And before that, our planning process was actually quasi-manual, and it was very loosely coupled as such. What it did was that it led to a lot of inefficiency, and it limited our ability to respond to the dynamic market conditions need. And as the diversity of size and the size of Flipkart business grew, this approach was, of course, not able to cope up with the growing complexity, and it started to become a blocker on how do we support the business growth. Now, just to put the things in perspective, the team would spend the whole month in analyzing the plan. Then they will do the same thing over and over again every month. And if there are changes in between, again, the whole process needs to be repeated, which meant that there was no room for left to drive the more efficiency and the improvement. The team itself was caught up in generating a plan throughout the month. At the same time, there were different teams. They were often shooting in different directions, which resulted in the lack of coordination, which means more inefficiency in the entire process. Now, with the pandemic in 2020, there was a massive jump in the e-commerce penetration, which not only was a boom for the e-commerce, but also brought a lot of visibility, a lot of disruptions across the supply chain, while people are working remotely, and we had to come together and solve on how do we deliver the customer ask, which was booming at that point of time. What we realized that we needed a central planning platform to overcome these challenges, because these processes cannot be left to people specific or working in silos. And these platforms need to optimize our supply chain operations. And we started this effort of creating the central planning platform.
So in 2021, Flipkart initiated an overhaul of its supply chain planning technology by creating a central planning platform that could enable it to grow rapidly and profitably. So specifically, this platform has two fundamental layers. The forecasting layer accurately predicts future demand using machine learning and deep learning techniques. This ensures that all our decisions are based on a robust understanding of future demand. The second layer is the operational efficiency layer, and it includes a set of optimization models that optimize decisions across the three core pillars of supply chain planning. So the first one being capacity planning, which involves allocating resources to ensure that we have the right supply chain capacity at every node in our network. The second one is inventory planning, which involves ensuring that we have the right products in stock closest to the customer so that we can deliver it to them as fast as possible. And then the third pillar is the network flow planning, which involves routing and scheduling of shipments for a given network design, right? So these models optimize decisions ranging from month-ahead planning to real-time decision making, leading to an overall optimization of the supply chain. So as you heard Vikash in the video, right? Before we built this platform, supply chain planning at Flipkart was done manually and in a fairly loosely coupled manner. So different teams were shooting in different directions. This platform has automated the planning process, making Flipkart more agile and efficient, and ensuring that all teams are aiming for the same goal. This platform combines the predictive power of machine learning and optimization. Uh, this powerful combination allows us to make intelligent decisions across the entire supply chain. And all our models are proprietary and utilize commercial solvers and specialized heuristics to solve the problems at the massive scale that Flipkart operates at. These models also work together as a team. So the forecasts are mutually consistent, and I'll talk about that in a little bit. And they're deeply integrated into the optimization models. The optimization models are coupled across capacity, inventory, and network flow planning. So this tight overall integration creates a highly optimized supply chain. So this combination of automation, optimization, and integration has transformed supply chain planning at Flipkart. It has already delivered significant cost reductions and incremental net sales, and these are built upon faster deliveries, lower manpower cost, lower inventory cost, and more agile and efficient planning. Given the limited time we have in this presentation, we will present an overview of our work on forecasting, inventory, and capacity planning. And we'll deep dive into just some of the elements in those three areas to give you a sense of the solutions that we've built. So we'll start with the discussion about our forecasting layer. So accurate demand forecasting is critical for optimal planning, whether we are talking about tactical resource allocation or real-time order fulfillment. In our business, demand can experience sudden shifts due to major sale events. So you're familiar with the big billion days that Flipkart hosts, and demand during that period goes through a massive spike compared to a regular day on Flipkart, right? So we may have sudden shifts in demand. We also have more gradual changes in demand. Like for example, if one of our mobile phones is nearing end of life, so the demand will change more gradually. Either way, the sudden shift or gradual shifts, these need to be incorporated into our demand predictions, but these are very difficult to capture in time-based correlations, right? Secondly, supply chain planning in our business involves a wide variety of use cases that rely on demand forecasts. So each use case requires forecasts at different granularities in terms of product, geography, and time. So for example, if we're trying to optimize how many units of a product we should buy, we will need to have a forecast for that product in some small geographic region, maybe a few pin codes, maybe over the next week. But if you're trying to optimize the marketing plan for that same product, we would probably need an estimate of the national sales for that product, maybe over a much longer period, maybe 3 months, right? So keeping all these challenges in mind, we decided to build an interconnected forecasting layer that will help us generate accurate demand forecast across our product portfolio and across the different use cases and with the corresponding requirements in mind, right? So our demand forecasting journey has progressed through several stages. Before we started, business teams used simple moving average methods, which relied solely on historical averages. These methods are simple, but they have poor accuracy because they have a recency bias. So we started by introducing statistical models like ARIMA and ETS, which helped us to capture time-based variability more accurately. However, these methods have poor accuracy for product categories like mobile and grocery that have sudden shifts in demand and high demand volatility. So we achieved the next jump in accuracy by combining machine learning methods like CatBoost with statistical models. So CatBoost CatBoost uses an ensemble of decision trees, and this approach can help capture demand shifts much more effectively. On the other hand, statistical models are able to capture time correlations. So a combination of these two methods helped us achieve much more accurate forecasts. In 2023, we transitioned to deep learning models, specifically LSTM and sequence to sequence models. Unlike traditional ML models, these models are able to capture complex trends without explicit feature engineering. These models also allowed us to include non-tabular data such as textual product descriptions and catalog images as features. These enhancements led to a further improvement in forecast accuracy. Finally, I should say that, all of these are kind of studied, well-known models, but optimizing these methods to achieve high accuracy across the broad set of use cases that we have and in our context required quite a lot of research and experimentation. So while we generate forecasts at different granularities, an important challenge is that we need these forecasts to be mutually consistent so that we can drive optimized decision making across the supply chain. So for example, forecast for a product across zip codes should be consistent with the forecast for that same product at a national level, right? This may not organically happen because we are building demand forecasts, all these demand forecasts independently. The other thing is that, none of these forecasts are perfect. Planners may have some strategic information that's not captured by these models, and so they may want to override or change some of these forecasts. So for example, a planner may know that we may have a sale on some, let's say, Apple mobile phones, right? Hypothetically. In that case, they will want to go and increase the forecast for Apple mobile phones at that level of granularity. We would want that change should reflect in the forecast for all mobiles and also for specific mobile phones, right? So those strategic inputs need to be propagated up and down the granularity chain for that set of forecasts. So we take a two-step approach to ensure consistency of our overall portfolio forecast. In step one, we generate the best possible forecast for all of our relevant time series, and these forecasts include the strategic inputs from the planners. In the second step, we execute a reconciliation model, which takes the related forecasts at different granularities and then generates final forecasts that are mutually consistent. So with this approach, we are able to generate forecasts across a broad set of granularities, and then for these forecasts also to be mutually consistent so that these can then feed into our optimization models and can lead to consistent decisions across the supply chain, right? Just to summarize, we've achieved about 10 to 50% improvement in demand forecast accuracy, depending on the product category that we're talking about. And like I said, right, higher accuracy in these forecasts enable better decision making in the operational efficiency layer. So switching over to the operational efficiency layer, the first pillar in that layer is capacity planning. So we run a complex supply chain that includes various resources, manpower, our own logistics, and third-party delivery carriers. The goal of capacity planning, like we've discussed before, is to have just the right number of resources at each stage in the supply chain so that we maximize delivery speed and we minimize costs. So our supply chain our supply chain network consists of a set of fulfillment centers or FCs where inventory is stored. These FCs are connected to a set of mother hubs that sort and aggregate shipments based on their destinations. We offload some of these shipments to third-party delivery carriers, which deliver shipments from mother hubs directly to the customers. The remaining shipments flow through a maze of our mother hubs and finally land at a delivery hub or a DH, which is a small facility close to the customer locations. Shipments are delivered to customers from these delivery hubs. So the goal of capacity planning is then to figure out how many resources we have at each of the hubs, how much transportation capacity we need, and then how many of our shipments we should offload to third-party delivery carriers and at what stage of the shipment journey. Now, there are two aspects that make supply chain or capacity planning challenging for us. First is the sheer scale of our network and our broad product portfolio. So just to give you an idea, we have thousands of facilities in our network which are tightly coupled to each other, and we deliver a huge range of products. And each product may need different amounts of handling capacity, right? So we have to kind of optimize across all those combinations. Secondly, our order patterns are highly variable. So like I said, right, we have multiple sale events during the year. The daily order volume changes pretty dramatically day on day when we have these sale events. So figuring out the optimal capacity level um, across the network with this much variability is fairly challenging. So we solve capacity planning through a multi-step process. We first predict how many shipments will flow from each FC to each zip code. And we do this for each day and for each product category. So now if you think about it, if we want to do this, we will need to know the demand for each product category at each zip code. We will need to know the inventory of that product category at each of the FCs. We will need to model the network connectivity, and we will need to account for how shipments are fulfilled. So, and what I mean by that is, see, in an ideal world, you'd always want to deliver shipments from the closest fulfillment center so that your costs are minimized and the speed is the highest. But that's not always possible. There are business rules that drive how we actually fulfill shipments. So we need to account for all of those business rules as well. Modeling all of these features from first principles is not practical. It just becomes too complicated. We take a much more ingenious approach. We model this problem as a bipartite graph where the FCs are source nodes, the zip codes are the demand nodes, the edges represent shipments between the nodes. And so now here is the novelty. We take as input estimated demand for each product category at each demand node, and we also take it as input the estimated number of shipments from each FC for each product category. And we also take as input data vectors that capture what a realistic fulfillment pattern for an FC looks like. Now, the goal of the model is to predict the actual supply and demand vectors such that we minimize deviation from the inputs that we just talked about while we satisfy all the constraints. So the key innovation here is that instead of modeling inventory, demand, fulfillment, all of these constraints from first principles, we allow planners to build estimates for the supply and the demand from each of the nodes at a node level, right? And they can do this based on historical data, but also based on the strategic insights they will have about the inventory position at each of the locations, the demand in each of the locations, and the way the network is changing and how company priorities around speed and cost are changing. In our business, a lot of this is fairly dynamic. It's very difficult to capture all of that dynamic nature into a set of constraints explicitly. So in letting the planners bring that strategic insight into as input into this model is where we brought innovation into this model. Even with this modeling approach, we ended up with a huge optimization problem because of the high dimensionality. And we solved this model by decomposing it into thousands of sub-problems, which are then solved in parallel. So that was the first step, the load estimation, which tells us how many shipments will flow from each FC to each destination. Then we solve a set of optimization problems to optimize manpower and transportation capacity across each node in the network. And we won't get into the details of every one of those problems. I'll just give you a couple of examples. So the first one is around the FC, right? So FC, the fulfillment center is obviously shipping shipments to customers, but manpower at an FC is doing several other things like inwarding inventory from sellers or moving inventory to other FCs. All of these activities require manpower. Some are more important than the others, right? And specifically the shipments to customers, the number of orders on a daily basis fluctuate quite a bit. So one of the problems that we solved is to minimize overall manpower cost at an FC by optimizing the cross utilization of manpower across all of these functions. The second problem I'll talk about is around allocation of shipments to third-party delivery carriers. So we utilize third-party delivery carriers to extend the reach and capacity of our supply chain. Our logistics cannot reach every part of the country. But the challenge is there are several delivery carriers across the country, and their speed, their cost, their reliability vary greatly depending on where they are in the country. So we solve an optimization problem that decides how many shipments to offload to what delivery carrier in which part of the country, such that overall we maximize we optimize the cost, speed, and reliability of our overall supply chain across the country. Right. So these are just a couple of problems. There are several other problems we solve to optimize capacity planning. In summary, our models for capacity planning have led to 10% more accurate estimates for how shipments will flow through our supply chain, which in turn has helped us increase utilization of manpower by 10%. And that has led to a significant reduction in supply chain costs. The other outcome has been that the capacity planning cycle has shrunk from 10 days to just 1 day due to the automation of this whole process, which has enabled planners to quickly optimize or re-optimize their plans in response to market conditions. So this was a quick summary of the monthly planning capacity process. I will now hand over the presentation to Gautam, and he'll talk to you about real-time fulfillment in capacity planning and the next pillar of operational efficiency.
Yeah. So the last piece of this entire capacity puzzle involves near real-time optimization to optimize delivery speeds for select orders. So the monthly capacity plan that Vikas just talked about, they flow into our supply chain execution systems. As orders stream into our app, our systems block capacities in real time and decide the delivery date for each order. Once the capacity on a day is exhausted, the remaining orders spill to the next day, and they will receive a longer delivery time. What happens during a monthly sale events is our daily sales jump by 2 to 4 times compared to a normal day. And this leads to a significant slowdown in delivery speeds for our customers. But not all orders are the same. For example, customers who subscribe to our paid VIP program, they expect fast deliveries even during sale events. So we enable this preferred customer experience by reserving network capacities to process high priority orders. So the challenge is the following, right? We do not know the exact demand for these priority orders. If we reserve too little capacity, we will see poor speed for those priority orders. If we reserve too much, we will end up with wasted capacity. So to solve this problem, we built a stochastic programming model that accounts for multiple demand scenarios and optimizes capacity reservation for high priority orders while minimizing the likelihood of any capacity underutilization. This model, it actually runs in near real time across all our FCs during sale events, and it has helped us increase our 2-day deliveries for high priority orders by more than 20 percentage points. Next, I will talk about the second pillar of our operation efficiency layer, which is inventory planning. The goal of inventory planning is simple, right? It is to have the right product selection in the right quantity and at the right location. And by doing inventory planning right, we can deliver the products to our customers at the lowest cost and at the fastest delivery speed. Now, here is the challenge. We have to achieve this goal while accounting for the demand and supply uncertainty across a huge product range. Second, we have a very long tail of products with sparse demands. And third, we have a constant churn in products. Our platform enables key steps in the life cycle of inventory planning. First is procurement planning, which is to determine when and how much of seller inventory to procure at each FC for each product. Second is inter-warehouse inventory transfer, or IWIT, where we rebalance the inventory across FCs to match the demand patterns across geography. And finally, liquidation and returns, where we dispose of the inventory that is not selling. The more accurate demand forecast from our platform, together with in-house statistical models that recommend optimal inventory quantities, they have helped improve the buying and placement decisions, leading to lower inventory costs. In today's presentation, I will just focus on the inventory rebalancing problem. So the goal of IWIT is to optimally rebalance the inventory across the FCs so that the products are placed closest to where the demand is. This will enable us to deliver faster at a lower cost. But first, let me start by explaining why we need to rebalance, right? So there are a few reasons. First, not all our sellers can deliver inventory to FCs across the country. Second, our procurement cycles are typically longer and our forecasts are never perfect. As a result, the initial placement of the inventory at the time of procurement is often not optimal. So what happens during an IWIT is trucks move the inventory between our FCs. The amount of inventory that we can move each day is limited by various operation factors, right? Such as manpower availability, storage availability, truck utilization, and so on. Given all these constraints, it is important to prioritize the right set of products and quantities that we want to rebalance every day. In the past, these IWIT used to be planned manually at Flipkart using a combination of simple forecast models and heuristic rules. And it was challenging for various reasons, right? First, accounting for uncertainty in demand forecast, the variability in the seller deliveries, a very large number of products and FC combinations. And in addition, the need to honor all the operational constraints, right? All of these was extremely difficult for planners to manually optimize the IWIT plans. Our goal was to bring the power of prediction and optimization to make the right inventory rebalancing decisions within the constrained environment. We decomposed the IWIT problem and solved it in 4 steps. First, we use the product and region level daily forecast to estimate the ideal inventory quantity for every product at every FC. We further built a demand sensing module to account for the forecast errors and the variability in seller deliveries. Together, this enabled us to reliably estimate if we have an excess or deficit inventory for every product at every FC. Next, given the constrained environment, we defined a utility function that assigns a priority to the deficit associated with every product FC combination. We then solved an optimization problem that maximizes the overall utility of the IWIT movements subject to all the operational constraints. We solved this optimization problem using large neighborhood search heuristics. The final step of our solution is to determine the optimal truck capacity needed to execute the plan from step 3. And this is solved for each lane independently using a simple integer linear program. Our IWIT process runs at different frequencies. Weekly for bulky product categories such as refrigerators. It runs daily for product categories such as cell phones, and it runs multiple times a day for grocery. This process is completely automated, and we rebalance close to 500,000 units every day across the country. The improvements to IWIT decisions led to better inventory placement in Flipkart. It resulted in a 50% increase in one-day deliveries and a 43% increase in two-day deliveries. More broadly, the higher accuracy of our forecast from our platform has led to better procurement decisions. This in turn has led to a 10% reduction in working capital and a 50% reduction in unhealthy inventory. Let me now hand it over to Prateek to talk through our implementation journey.
Thanks, Gautam. So we embarked on this journey in 2021 when our sellers and operations teams were struggling to cope with the demand surge due to COVID. This was a period of opportunity for us to cater to this demand and establish itself as the top e-commerce destination for India. We had to grab this opportunity with both hands or run the risk of falling behind. We started by building demand forecasting models for individual teams that use them to plan the procurement of inventory from sellers. As we started to see success in strategic categories like cell phones and grocery, we started getting more and more inbound requests internally to build models for different categories. By the end of 2022, we had 40 unique models catering to a variety of demand forecasting needs across categories and use cases. Now, in parallel, our supply chain disruptions and rapid demand scale up were playing havoc with our existing capacity planning processes, which were just not able to keep pace. We started by building out the load estimation model, which Vikas talked about earlier, which helped the operations teams understand the expected loads at each part of the network and then plan manpower and other resources for the same. These initial seeds of machine learning driven work saw great traction, and we were able to take this momentum and kickstart our efforts on building the more traditional operations research optimization use cases to support inventory, supply, and network planning. In early 2023, we built a blueprint for a connected central planning system that would bring together all of our ML and OR efforts in a single central planning platform. We built this out iteratively and were able to go live with the first version of the system by early 2024. Along the way, we haven't just built these ML and optimization models. We've built a software platform and layer that enables end-to-end solutions for planning, including visibility, explainability, and human intervention. We've also built robust governance processes to track accuracy and effectiveness of our models. Let's now hear from some of our business leaders and users on how this platform has impacted their ways of working and helped them deliver business impact.
The intelligence provided by the central planning platform has been a complete game changer for how we plan our inventory and placement decisions at Flipkart. Earlier, we used to be dependent on basic techniques and qualitative feedback from business teams, which made our decisions pretty debatable, right? Now, with advanced deep learning models driving systemic forecast, we are a lot more accurate and confident about our decision making the entire process extremely seamless. It's not just the increased accuracy that has helped us. Having forecasts available at the granular level of product, geography, and time, coupled with our identity optimization models, has enabled us to place inventory closer to our customers, leading to a 50% increase in deliveries done in 1 day and about 40% increase in deliveries done in 2 days. This has also helped us reduce the unhealthy inventory levels by around 50%, freeing up millions of dollars of working capital for our sellers. We have partnered with the planning tech team to build the capacity planning and network planning capabilities. This platform has made our monthly capacity planning process much more effective and efficient. We are now able to predict loads in our network much more accurately and are able to apply a scientific approach to plan our resource capacities. In addition to the great technology, in my mind, a key differentiating factor has been the capability to bring together historical data and optimization algorithms with strategic business insights in building our capacity plans. We work in a very, very dynamic business context, and this capability has helped us achieve millions of dollars of savings in supply chain costs through better resource utilization. The platform has also helped us achieve major improvements in our delivery speeds. Our ability to dynamically reallocate capacities in our network has enabled us to deliver 20% more of our priority orders within first 2 days during our big sale events. We have also been able to achieve more than 10% reduction in idle times for shipments in our network, leading to significant improvement in our overall delivery speeds. These are areas where we had been trying to solve for a while. This platform has finally helped us achieve those goals. And
the central planning platform, what it has done for Flipkart planning team is that it has allowed us to scale our impact very, very efficiently with a rapid growth in the Flipkart business. Before this platform was built, we kept on adding people as the business was scaling up and the new businesses were added. But now if I look at our systems, even though some operations have gone 5x in the last 6 months, we are still able to operate with a very, very similar size team. The systemization and the automation which this team and this platform has enabled us, it has led to the significant reduction in the planning cycle time. For instance, if you look at our planning cycle time earlier was almost 10 days, right? From getting a demand plan to converting it to a operating plan for operations. That time has now gone to a 1 day kind of timeline, which has allowed us to run these planning cycles many more times as the outside environment is changing for Flipkart. It has led to more nimble, more responsive, more accurate plan as we are tackling much more volatile environment and allowed Flipkart to be more responsive for any changes that we are doing in the market.
So I'm mindful of time. So this is the last slide, but I'm thinking I'll just summarize very quickly and then we can take some questions. So in very quickly, right, I think just summarizing, our platform combines the strengths of machine learning and OR to optimize decisions across the three pillars of supply chain planning. And tight coupling of these models enable the platform to deliver significantly more value than the sum of its parts. Overall, this platform has delivered significant cost savings and incremental net sales, and that's been done over a short period of 3 years. You can see some of the metrics on the slide. I will not go through those metrics. I'll just pause there to see if we can take some questions over the next 6 minutes. Thank you for your time.
Thank you, because I think in the interest of time, we'll go directly to the questions which has been already put into Q&A. And in the interest of time, I'll also tell that to skip all the anonymous attendees answers. So we can go with the first question, Akshita Shroff. Major challenges with the current forecasting system. Yeah, you can just.
Gautam, do you want to take that?
Yeah, sure. So I think, see, there are a few challenges, right? One is what we learned is that, there's no like one size fit all solution, right? And what we learned is that the right forecasting model tends to depend on the category, because every product category has its own nuances, different market dynamics, and so on. And in our experience, majority of the benefit will come from finding the right features, right? For more than the model complexity, is basically getting the right features and signals that will help us do a better forecast.
Okay, next question. Sovi Bhattacharya. How decompose subproblems were solved?
I'll take that quickly. So that, I mean, it depends on the model, but like I said in the presentation, we use a mix of commercial solvers and internal, like purpose-built heuristics. And commercial solver, for example, is Gorobi is the one that we're using.
Okay. Dibasput, yeah.
No, I think the next one is more of a comment, I think, from Dibaspati. Yeah. So maybe we should skip to the next question.
Okay.
I think that's maybe Gautam, you should take that on forecasting.
Forecasting, yeah.
Yeah, I'll take that. So how frequently is the models retrained? So varies with the use case, Tilak, right? So in some of the use cases, we retrain them almost every week, right? So for example, in some cases, we still use ARIMA models, which we retrain very frequently every week. In some cases, we move to deep learning models where we tend to train them probably once every 3 months. The important thing is to have model governance system in place. So we do monitor the model's performance very thoroughly, and then whenever we see degradation in the accuracy, we tend to retrain those models. I think there were more questions in that. Let me.
I think Nitish's question is kind of related to that as well.
Maybe
yeah.
I can take this one. By the way, I've responded to a lot of the questions already. So folks should be free to go through the answered section of the Q&A, because otherwise we would not have been able to cover everything live. And whatever we are also just dismissing. So to Nitish's question, we've actually built internal tools that which our planners use to consume the forecast created. It's almost like an Excel kind of an interface. We've taken heavy inspiration from tools like Anaplan, to build an interface where they can consume these forecasts, make edits to it, give their suggestions, have discussions with their peers on what's the right forecast. So we've built a great human in the loop system. And we've also built approval mechanisms on top of this where people can suggest changes to the forecast. Those changes can then be discussed, approved by the relevant folks, and then propagated downstream into the system. We measure all metrics around forecasts very closely. So both the original forecast created as well as the modified forecast and the extent of override, all of these metrics are tracked at a very granular level for each forecast that is generated every week. And we review this internally to figure out both what are the improvements we need to make to the forecasts, as well as how do we better build tools for planners to engage with these forecasts.
Pratik, you want to take the next one too? Siddharth.
Sure. So
Siddharth
for the manpower planning model, it's largely about finding the right balance, right? So the two metrics that we look at, one is manpower utilization, and the other is a metric that we call breach, which is essentially saying that if I wanted to process X products today, or if I got X orders today, how many of them was I able to process at that node, and how many of them spilled over to the next day, right? So the percentage that I'm not able to process on a given day is essentially breach. So it's a balancing act between the two. I think when we started this exercise, we were focusing on reducing breach. And once we were able to bring down breach to a certain level, then our focus shifted on more towards improving our manpower optimization. Now, this equation again can look very different at each part of the node depending on how the manpower staffing looks like. So there's no one answer. It's essentially a balancing act between these two metrics. I also you talked about the constraint on the processing time. So there are two parts of manpower and capacity planning. One is more long term in nature, where we have been progressively working on bringing down the total time taken from 10 days. We brought it down to 1 day. It's not a constraint. It's more about continuous improvement so that the teams can run this more frequently. And for the real time, I think Gautam can probably talk about the time period constraints there.
This is for manpower planning in real time. Oh, okay, yeah. So the processing, so yeah, I think the real time, the way we solve it is, we try to break it up into two pieces, right? We have a predictive module, which tries to assign or distribute the capacity across the cohorts based on the model predictions. And we also have a reactive module. And what the reactive module does is basically it reacts to the demand trends in near real time and tends to rebalance those capacity distribution, right? And what the way we've solved it is the predictive module can run at longer or the duration between two consecutive predictive model runs can be longer, right? We can run it every 15 minutes or every half an hour. And the reactive module is much simpler, lightweight, and it tends to run every few minutes. So that is how we try to solve the real-time aspect of it.
Okay, hey guys, I think we are running out of time now. So
Yes.
thank you again for excellent presentation. Really enjoyed it. And for those in the audience, I did send out a link over the chat that a recording of this presentation should be there in a couple of days. It's listed under past webinar. So thanks again for this great presentation. Gautam, over to you.
Yeah, I think we had an excellent presentation. I heard this earlier also in Indianapolis last month in April. But the thing is that they did an extremely good job in a very short period of time, because I had a presentation of Flipkart in the 2020, I think, when they came to IIM Ahmedabad with Devjit Roy. I remember that. And I think from there, what they have come to is really phenomenal. I would like to just state that we are doing this competition similar like Edelman in India. And whoever is listening to this, actually, if you are doing a good work, please send a 3-page outline what you have done, like Edelman Prize and other. And we would like to actually come back to you to give a feedback, or would you like to invite us if it gets selected as a finalist in January at IIM Ahmedabad? With this, I would like to end this, and if you have any question, you can just write to them directly, or you can look into this videograph once again when it will be available online. Thank you very much.